Now I'd like to remind you of two special right triangles that you learned about in geometry. One is the 30, 60, 90, and the other is the 45, 45 right triangle. Now, the special ratios that you learned back in geometry were that the short side is 1, your longer leg is the square root of 3, and the hypotenuse is 2. I remember this just by counting. If you just think, okay, 30, 60, 90, you're going to count 1, 2, square root of 3. Kind of corny, but it helps me out. 1, 2, square root of 3. Just count. Same thing with the 45, 45. If you just count 1, square root of 2. And because this is an isosceles triangle, that would mean that the base angles must be the same. So both of the legs are 1, and the hypotenuse is square root of 2. I'm going to use the special right triangles to help me find the values for x and y in this triangle in example 2. So if you remember the special right triangle, that is the 30, 60, 90, 1, 2, square root of 3. So what I'm going to do is I'm going to use ratios and proportions to find what x and y are equal to. So one of the proportions that I'm going to set up is, and by using just similar triangles, is I'm going to use adjacent over hypotenuse. So, and I write this out so I can remember which side I'm going to be using. So in this triangle, if I'm looking for this angle, by the way, is going to have to be 30 degrees. So if I'm using the 30-degree angle, I'm going to say adjacent is y, hypotenuse is 20. So y over 20 is equal to, now if I use this 30 degrees here, the adjacent is square root of 3 over the hypotenuse is 2. So I'm just going to use this proportion to solve for y. So if I do product of the means is equal to product of the extremes, I end up with 2y is equal to 20 square root of 3. If I divide both sides by 2, I get y is equal to 10 square root of 3, not 2. So 10 square root of 3. Now I could do a Pythagorean theorem to find x, or I could use a proportion again. I'm going to use a proportion, and I'm going to find x. So this time I'll still use the 30-degree angle, but if I'm trying to find x, I'm going to use opposite over hypotenuse, which is my sine ratio. So opposite over hypotenuse, and I'm going to use the similar triangles. So opposite the 30 degrees is x over the hypotenuse is 20 is equal to, now in this triangle, opposite would be 1, hypotenuse is 2. So once again, with the product of the means equals product of the extremes, x is equal to 10. So I found both x and y. Now in example 3, I'm going to find x and y again, but my triangle is now a 45-45 right triangle. I'm going to use the same strategy I used in the last case, and I'm going to think about my special right triangle, where I have a 45-45 and my sides are 1, 1, square root of 2. So same strategy. I'm going to think about this 45-degree angle, and I'm going to think about opposite over hypotenuse. So opposite over hypotenuse, I would have 7 over y is equal to, now go to the similar triangle, looking at the 45 degrees, opposite over hypotenuse, 1 over square root of 2. And if I do product of the means equals product of the extremes, y would be equal to 7 square root of 2. Now x, I could do the same thing, but I really don't need to. It's a 45-45 right triangle. I know the legs have to be the same, so x would have to be equal to 7. Example 4 is a little bit different than the last couple of examples I did with the 30-60-90 and with the 45-45 because this isn't a special triangle. So what I'm going to do this time is I'm going to use my ratios for my right triangles to find what A is, what C is, what angle B is. I'm going to start with the easiest thing I can find, and that would be angle B. Angle B would have to be equal to 90 minus 20 degrees. Because in a triangle you have 180 degrees, 90 is already here for C, so that means the sum of these two angles must be 90. Also, theorem in geometry you might remember is that the sum of the two acute angles in a right triangle has to equal 90 degrees. So angle B is 90 degrees. The next thing I'm going to do is find little a. So little side A, that's the side opposite the 20 degrees. Now, I know these two angles. I know this is 24, so I'm going to use this. What I don't know is A. So if I'm thinking about the 20 degrees, A is the opposite side, and 24 is my adjacent side. And if you remember back to your ratios, opposite over adjacent is tangent. So I'm going to say that the tangent of 20 is equal to A over 24. Now I need to use my calculator on this, but first I'm going to multiply both sides by 24. And now I'm simply going to put this right into the calculator. 24 times the tangent of 20, and A is approximately 8.7. Now when I find C, I could use a ratio again, or I could try to make it real easy on myself and just use a Pythagorean theorem. So I would have C squared is equal to A squared plus B squared. C squared is equal to 8.7 squared plus B squared is 24 squared. So C squared is 65,169. I got that straight off of my calculator. And by taking a square root, C is about 25.5.